What's up, everybody? It's Dan from SageMathTutoring.com, and I'm back with another video. This time, having to do with factoring trinomials, quadratic trinomials. So let's see. I don't know if I want to do all of these, but I'm gonna do, well, maybe I will. So there's really two kinds of trinomials for my student who's watching this. There's really two kinds of quadratic trinomials that you're going to have to factor. One kind of quadratic trinomial is the one where it's sort of like normal looking. And what I mean by that is the coefficient, the leading coefficient is just an invisible one that is in front of the whole thing. And that's right there. Okay. Now, unfortunately, you're going to have to also know how to factor something where there's a leading coefficient other than one, which is sort of a whole different story. Okay, there's some similarities there, but it's the case that you're going to have to use a different strategy for those. So we'll start with these, and I'm going to break it down into sort of like distinct steps here. So looking at problem number one. So what you want to do when it's the case that there's a leading coefficient of one that's in front here is you focus on the constant at the end and you basically list all of the factors of that constant. Okay, now at a certain level of experience, you're not always going to have to do that. But in the beginning, you might want to do that. And what you're doing is listing all the factors. In this case, it's just 1 and 3. But also, if you think about it, -1 times -3 would also give you a +3 when you multiply them together, right? So 1 times 3 gives you 3. -1 times -3 also gives you +3. So what you're really doing, though, is you're looking for the pair of factors in this list that would add to the coefficient of the middle term. So in this case, we're looking for the pair of factors that would add to +4. Now, obviously, these are the two that would do it. So therefore, we can go ahead and move to the next step. So we can say, let's say step number one is factor the constant. We can say step number two, find the pair that works, we'll say. And then step number three, factor accordingly. Okay, that's the step that we're on right now. So what does that mean, factor accordingly? Well, what that means is you literally set it up so that you have two parentheses multiplied times each other. You're going to have your x, you're going to have your x, and then what goes in the other space? Well, it's going to be the two special numbers that you circled. It's going to be +1 and +3, okay? And yeah, that's how you do it. It's actually just as simple as that. So I don't know if I'll do all these, but I'll do everything that's here. Okay, we'll do all these here. All right, because otherwise it's a little too tedious. So looking at problem number 4, we're going to do the exact same thing with problem number 4. So the constant is -6. So I'm going to put that up here. Okay. Now, what are the factors of -6? Well, we have 1 times -6 gives you a -6. We have a 2 times a -3 gives you a -6. But we also have a -1 times a +6 gives you a -6. And we have a -2 times a +3 giving you a -6. Now, you must be very careful to make sure that you exhaust all of the possibilities and also take into account the fact that since it's negative, it's going to be the case that one of the numbers is going to be positive and the other one is going to be negative. Or you could say that one of them is going to be negative and the other one is going to be positive, right? So, and let's actually go back to what we were doing in the last problem before we were investigating +3. So in that case, we had a 1 times a 3, so that's a +1 times a +3, but we also had a -1 times a -3. So if you are looking for the factors of a positive number, then it's the case that they're either both going to be positive or they're both going to be negative. If you're looking for the factors of a negative number, that means that whatever the two numbers are, they're going to have opposite signs. Okay, so regardless, looking at this -6 situation, we're finding the pair that works now. Well, what does that mean? We're finding the pair of numbers that would add to the middle coefficient. The middle coefficient is -1. So clearly the numbers that we would want to work with are these two, because it is the case that +2 plus -3 gives you -1. So then we're looking at step number 3, which is to factor accordingly. What does that mean? Well, separate it into two separate parentheses. We're going to have our x, we're going to have our x, and we're going to have our +2, and we're going to have our -3. Okay, so that is how you do that one. Hopefully this is sort of making sense. Looking at problem number 7, we're going to be factoring -12, which means one factor is going to be positive, the other one is going to be negative. So looking at 1 times -12, that's a possibility. 2 times -6, that's a possibility. 3 times -4. But we could also say -1 times +12, -2 times +6, -3 times +4. We accomplish step number 1. Step number 2, find the pair that works. We're looking for two numbers that multiply, or add rather, to -4. It looks like this pair would do it. So step number 3, factor accordingly. We have t, we have a t, we have a +2, and we have a -6, and then we're done. Look at that. How easy is that? Come on, get it out of here. Done. So it's actually really easy when you break it into steps like that. Number 10, looking for factors of +5. Well, that would be +1 times +5. But we also have -1 times -5, right? So those are possibilities. We're looking for two numbers that would add, however, to this +6 here. So step number 2, finding the pair that works. Obviously, it's going to be this +1 and +5. Step number 3, factor accordingly. X plus 1 plus 5. Okay, so that's that one. Let's see. Moving on to the next one, problem number 13. Step number 1, factor the constant. What is the constant? The constant is -3. So we're going to have 1 times -3, or -1 times +3. Step number 2, find the pair that works. Which of these two numbers add to the middle coefficient of -2? That would be this pair. And step number 3, factor accordingly. X plus 1 minus 3. Done. So that's that one. Getting close to the end here. Looking at problem number 16, step number 1, factor the constant. We have 20. We have to factor that, so it's going to be 1 times 20, 2 times 10, 4 times 5. But it could also be -1 times -20, -2 times -10, and -4 times -5. So those are possibilities. Step number 2, find the pair that works. We're looking for the pair of numbers that add to a +12. So clearly that's going to be the 2 and the 10 right there. 2 and 10. So step number 3, factor accordingly. We're looking at x plus 2 plus 10, and then we're done. Look at that. Boom. All right, one more of these. So you can see these are like not too bad. They're kind of like easy once you get the hang of it. Okay, this one's weird. Okay, this one's very weird. Yeah, I think we can go about it in the same way though. This time we are going to go about it in the exact same way, which means we're going to use these steps. Part 1 is factor the constant, or really I should say, or last term. All right, because in this case the last term is a variable. So we're going to factor that y squared. So we have a y squared here. Now, what are the possibilities for y squared? Well, certainly 1 times y squared. But it's also the case that it could be y times y. That gives you y squared, right? But it could also be the case that it's -1 times -y squared. And it's also the case that it could be -y times -y. So we just factored the last term. Part two, find the pair that works, meaning which of these pairs is such that it would add to the middle coefficient, okay? Now, what you have to do with this, though, is you have to rewrite the middle coefficient as 2, kind of rewrite the whole term, rather, as 2yx, and then the so-called middle coefficient would actually just be this part. All right, I know that might be confusing. We'll do a couple of the other ones that are sort of like that. In fact, for these, maybe that should be the first step. So what you're doing is you're looking for which pair would sort of add to 2y, and 1 plus y squared is just 1 plus y squared, so that wouldn't work. Y plus y gives you 2y, so that would work. So therefore, we can move on to step number 3, which is to factor accordingly. We have x, um, we have x, we have plus y, we have plus y. Okay, now I know that can be confusing, so we will do a couple more of those. All right. And I would say for these, anytime you have this variable at the end, perhaps the preliminary step would be to just rewrite that middle term so that how sort of the um, variable that we're mostly focused on is this x. So you're going to want that x to be on the right side. All right, so we'll see what that looks like. Let's take a look at problem number 20, actually. So looking at problem number 20 right here, we could sort of do the same thing where the preliminary step would be to write the a on the right side, and therefore it would look like a squared minus 4b times a plus 4b squared. And the reason for that is because we want to be very clear that the coefficient is sort of this thing right here. Okay, that's the coefficient of the middle term. From that point forward, we can then just go through the motions of the original strategy. And the original strategy says factor the last term. The last term is 4b squared. So it could be helpful to sort of break it up. I mean, if we were to do the factors of 4, it would be 1 times 4, 2 times 2, but also negative 1 times negative 4, negative 2 times negative 2. If we were to do the factors of b squared, it would be 1 times b squared, also b times b. We could also say negative 1 times negative b squared and negative b times negative b. Now, if we were to sort of splice all that together, imagine you just sort of model this for a moment. It would be a 1, 4, 2, 2, negative 1, negative 4, and negative 2, negative 2. So I'm just going to kind of copy that part. But I'd like to work with only this pattern here, where there's a 1 here and a b squared there. So we're going to say b squared across the board. B squared, b squared, b squared. And there's this invisible 1 here. Okay, so in other words, I'm applying this top row to all of these. All right, I know that's confusing, but it is what it is. So that's the reality with that. So those are some factors, but unfortunately we're not done because um, we could then apply this row to an entirely new batch. So what we're going to do is we're going to repeat the old batch, 1, 4, 2, 2, negative 1, negative 4, negative 2, negative 2. But now we're going to work with this green pattern of B and B. So that would be B, 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 B. So that would work as well. Now we would have to work with this third pattern. So repeating this structure again, however, I'll keep that in red. So that's going to be 1, 4, 2, 2, negative 1, negative 4, negative 2, negative 2. But now repeating the yellow pattern, well, that would be negative in front of here and a negative b squared. So negative b squared, we'll say negative 1, negative b squared. we would have a negative 1 in front of this and a negative b squared. We would have a negative 1 in front of this, which turns that into a positive, and a negative b squared here, which turns that into a positive, becoming a b squared. And then we would have a negative 1 times this, turning that into a positive, times a negative b squared, turning that into a positive, and that would turn into a b squared. So when it comes to all the positive numbers, I'll just erase the positive symbol. And lo and behold, it looks like um, that's what we would get. Yeah, that's what we would get for that one. So cool. All right, interesting. And then finally, we would have the purple row down here. So we could repeat the original structure. We have 1, 4, 2, 2, negative 1, negative 4, negative 2, negative 2. But now we're doing the purple one where it's negative b, negative b. So it's going to be negative b, negative b, negative b, negative b, negative, which turns that into a positive 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 b there. Okay, erasing all the positive symbols. So these would be all the factors of 4b squared. Believe it or not, it's kind of a little crazy. So we accomplished step number 1. Okay, we accomplished step number 1. Uh, find the pair that works. In other words, find the pair that adds to negative 4b. Well, if I add this, that does not give me negative 4b. I could already see what would work. It would be this right here. If you were to add those, no, it would be this right here. If you were to add these, that would give you a negative 4b. So then we can factor it such that it says A, um, and then we would have minus 2b minus 2b. Okay, so that one was terrible. And that's one way of going about that. The way that we sort of approach that one would work under all circumstances. So we will keep practicing. We will do problem number 21 as well. So when it comes to that one, ask yourself what's sort of the main variable, or we could say what's the first variable mentioned. That would be x. So we're going to rewrite this as plus 6yx. Okay, so it's really x squared plus 6yx minus 7y squared. At that point, we have a negative 7y squared as the thing that we need to factor. Let's break that up into negative 7 and then y squared over here. So 1 times negative 7 would give you a negative 7. Also negative 1 times positive 7 would give you a negative 7. 1 times y squared would work there. Also y times y. We could also say negative 1 times negative y squared. We could also say negative y times negative y. So working with this structure, we have a 1, negative 7, we have a negative 1, we have a positive 7, and let's work with the top row here. It would be 1 and y squared, so we'd have 1 times 1, which is just 1, and we would have a y squared there. We would have a negative 1 times 1, which is just negative 1, and then we would have a y squared there. We then repeat the red circled structure. That is 1, negative 7, negative 1, 7. We're now going to work with the green row. That's y and y. So we're going to have y, 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 y. Okay, so that's that one. Repeating the red structure again. 1, negative 7, negative 1, 7. And working now with the let's make it the black row here. We have negative 1, negative y squared. So that becomes negative 1, negative y squared, which turns it into a positive y squared. Negative 1, which turns it into a positive 1, and negative y squared, which turns it into a negative y squared right there. Let's erase the positive symbols. Okay, erasing the positive symbols. All right, we have one more row to work with, which means we have to rewrite that entire thing again. So that's going to become, let's get rid of that. That's going to become 1, -7, and -1, 7. Okay, so working with the last row, that will be the sort of purple row there. We have -y, which means it's going to be -y, negative, which turns into a positive y, negative, which turns into a positive y, and -y there. Let's erase the positive symbols. Okay, so there we go. And what we're doing is we're looking for a pair that would add to this positive 6y here, right? So what would add to a positive 6y? Let's see. Let's see. Okay, it looks like that one right there. So -1y plus 7y would give us a positive 6y. So then we can just separate our parentheses. We have x, we have x, we have -1y, which is just -y, and we have positive 7y there, and then we're done. Okay, so that's how you do that one. Okay, so this is the second kind of factoring trinomials problems that you're going to have to deal with. We're going to, let's see, we're going to tackle um, these. And we're going to have to throw in one of these weird ones here, right? Okay, with the variables at the end. So this one is significantly more challenging. Um, not necessarily challenging than the last 2 or 3 problems we did, but the first batch of problems that we did in the previous slide, uh, that's relatively easy compared to this. So we're going to figure out how to do this right now. So we have 2x squared minus 3x minus 2. So step number 1, find magic number. Okay, find magic number. Step number 2, um, factors of magic number. Step number 3, find the pair that works. Step number 4, explode middle term. And step number 5 is sort of a catch-all, factor by grouping. All right, so that's what we're going to be doing. So step number 1, find the magic number. What does that mean? The magic number is the result of multiplying the first coefficient and that constant. That's -4. Done. Step number 2, find the factors of all factors of the magic number. Okay, we know how to do that. -4. We have 1 times -4. We have 2 times -2. We have -1 times +4. We have, and that's it. So then we want to find the pair that works. In other words, what are the pair of factors that add to the middle term, -3? Well, clearly that would be the top row. All right, would add to the coefficient of the middle term. So we just found the pair that works. Step number 4, explode the middle term. That means you rewrite the original thing, only you're now exploding the middle term in accordance with these 2 numbers. It's going to be plus 1x minus 4x minus 2. Notice how we didn't change the value of anything. We could always just combine these like terms and get -3x again. Okay, so step number 5, factoring by grouping. Now, what that means is you focus on one pair of terms at a time, and then you factor out the greatest common factor from each. Now, the greatest common factor from the first 2 terms is just x, because x times 2x gives you 2x squared, and x times 1 gives you 1x. So then you factor out that x, and then you ask yourself, okay, x times what gives me 2x squared? Well, that would be 2x. And then we can say x times what number over here gives you positive 1x? Well, that would be plus 1. okay? So you factor out the greatest common factor of the first two terms, and then you do the same with the second two terms. And in this case, the greatest common factor is a -2, so we're going to have a -2. So you must write -2. You don't want there to be a space here. You want to write -2. And it's the case that inside here, -2 times what would give me -4x? Well, -2 times 2x would give me a -4x. -2 times what number over here will give me a -2? Well, that would be a +1. Notice how these two parentheses match, and that's how you know you're doing things correctly. I should say, well, then the final step of the factoring by grouping is to separate it into two separate parentheses. What goes in the first parentheses? Well, that would be the repeat parentheses. We have a repeat of 2x plus 1 here and here, so we're going to put that 2x plus 1 right there. What goes in the second parentheses? Well, all the other stuff. We have this sort of x hanging out here, and we have a -2 hanging out here, so that's going to go there, and then we're done. So that's how you do that. Find the magic number first by multiplying these two numbers here. Uh, List the factors. Here they are. Find the pair that works. There it was. Explode the middle term. We exploded that middle term, and then we factored by grouping, which means focusing on one pair of terms at a time, factoring out the greatest common factor, and then hitting it with that final move right there. Okay, so that's how you do that one. Looking at the next one. So we have 6x squared plus 5x minus 6. 6x squared plus 5x minus 6. Okay, step number one, we're going to find the magic number. That's -36. Step number two, what are the factors of the magic number? Well, -36 up here. We have 1 times -36, we have 2 times -18, we have 3 times -12, we have 4 times -9, and we have 6 times -6. And it would be all the same stuff again, except the first number negative, second number positive, so -1, 36, -2, 18, -3, 12, -4, +9. And finally, well, we actually don't need to say -6, +6, because in a way that's kind of mentioned right there. Step number three, find the pair that works. In other words, which of these pairs adds to the middle coefficient? Which of these pairs adds to 5? Well, that would be this last one right here. -4 plus +9 is +5, so therefore we can move to step number 4, explode the middle term. We have 6x squared. The 5x turns into -4x plus 9x minus 6. Step number 5, factor by grouping. Well, we focus on one pair at a time. What's the greatest common factor of the first pair? Well, 6 and -4, the greatest common factor there is 2, so it's definitely going to be a 2. And with regards to the x squared and this x, the greatest common factor is just an x, so that's going to be an x in there. So then you ask yourselves, 2x times what number gives you a 6x squared? Well, that would be 3x. And then you ask yourself, 2x times what number over here will give you a -4x? Well, that would be a -2. Um, Focusing on the next pair, what is the greatest common factor of 9x and -6? Well, that would be a +3. So then you have your parentheses. You ask yourself, 3 times what number gives you a 9x? Well, that would be a +3x. And then 3 times what number over here would give you a -6? Well, that would be a -2. Notice how these parentheses match, which is a sign that we are on the right track. At that point, you're ready for the last part of factoring by grouping, which is to draw the two parentheses. One of the parentheses is going to be the repeat parentheses, and then the other parentheses is going to be all the other stuff. In this case, that's 2x plus 3, and then you're done. All right, so that's how you do that one. Moving on to another one, looking at problem number 7, which is 2a squared plus 5a plus 3. All right, so finding the magic number, 2 times +3 is +6. What are the factors of the magic number? Well, that's 1 times 6, 2 times 3, also negative. -1 times -6, and -2 times -3. Step number 3, find the pair that works. In other words, what's the pair that adds to +5 right here, this +5? Well, that would be this pair right there, this pair right there. Step number 4, explode the middle term, 2a squared plus 2a plus 3a plus 3, and then we factor by grouping, which is step number 5, focusing on one pair at a time. What's the greatest common factor of the first pair? That would be 2a. 2a times a gives you the first term, 2a squared. 2a times 1, +1, gives you the second term, this 2a right here. So then you could do the same with the next pair. What's the greatest common factor of 3a and 3? That would be +3. So then we would have 3 times a would give me this 3a right there, and 3 times +1 would give me this 3 here. 3 times that +1 would give me that 3 there. The final step of factoring by grouping is to make parentheses. One of them is going to be the repeat. The other one is going to be all the other stuff, 2a plus 3. Okay, so that is that one. Moving on to the next, which is 8x squared minus 4x minus 24. Minus 4x minus 24. Okay, we could find the magic number, although I am noticing that with this one, we could factor out a 4 right away. So it is the case that 4 happens to be the greatest common factor of all the terms. So 4 times 2x squared would give me an 8x squared. 4 times negative x would give me a negative 4x, and 4 times negative 6 would give me a negative 24, which means that all we really have to do is apply the method we've been using to this blue part right here, okay? So first you find the magic number. The magic number would be 2 times -6, which is -12. So then we could go ahead and find all the factors of -12. That's 1 times -12. That's 2 times -6. That's 3 times -4. Also -1 times +12. -2 times +6. -3 times +4. So then we're going to move to step number 3, find the pair that works. In other words, what's the pair that adds to this -1 that's right there, okay? Not this, we're kind of ignoring the top one. We're working with this new updated version. So what's the pair that adds to this -1? Well, that would be this one right here. It is the case that 3 plus -4 would give me a -1. So step number 4, explode the middle term. Notice how I rewrite that 4 on the outside, though. I'm actually going to use brackets now. I rewrite that 4 on the outside. I'm exploding the middle term. We have 2x squared plus 3x minus 4x minus 6. Step number 5, factor by grouping, focusing on one pair at a time. Notice how I rewrite the 4 on the outside. What's the greatest common factor of 2x squared and positive 3x? Well, that would just be x. So what goes in the parentheses here? X times what gives me a 2x squared? Well, that would be a 2x. X times what number gives me a positive 3x? Well, that would be a positive 3. What's the greatest common factor of this? The greatest common factor of -4x and -6 is going to be -2. So we have -2 times parentheses. -2 times what number gives me a -4x? Well, that would be a 2x. -2 times what number gives me a -6? Well, that would be a positive 3. Almost done with factoring by grouping. At that point, we are still going to rewrite that 4 on the outside, but now we're ready for that last move where we have the 2 parentheses. What goes in the first parentheses? Well, that would be the repeat parentheses, so that's going to be 2x plus 3. What goes in the other parentheses will be all the other stuff, x minus 2. Okay, so then we're done with that one. All right, looking at the next one, 3y squared minus 6y minus 24. Okay. Is there a greatest common factor for all 3 terms? Well, actually, yes. In this case, there is. It's a 3, so it's a 3 times y squared minus 2y minus 8. So how did I know that? Well, 3 times this y squared is 3y squared. 3 times this -2y is a negative 6y, and 3 times this negative 8 is a negative 24. Now, here's the beautiful thing. Now we have like a normal looking trinomial where we could use the strategy we used for the first batch of problems earlier in this video, where the directions for that are to simply factor the constant at the end, right? These are the previous directions. Factor the constant, find the pair that works, factor accordingly. So that factoring the constant means we're only factoring this part right here. So we have negative 8. What are the factors of negative 8? 1 times negative 8 would work, 2 times negative 4 would work, negative 1 times positive 8, and negative 2 times positive 4. Find the pair that works. What's the pair that works? Well, it's the one that would add to a negative 2 here, so that's going to be this second pair right there, right? And then factor accordingly. Look at this. We don't have to do any factoring by grouping or anything like that because at the end of the day, there's just an invisible 1 in front of that y squared. But we do need to make sure we preserve that 3. We're going to transfer the 3 to the next line. But we are ready to break this up into 2 separate parentheses. It's going to be y, it's going to be y, and a plus 2 and a minus 4 as a result of the pair that works. And that's how you do that one. Okay. So that one was an interesting one. Looking at problem number 16, we have 6x squared minus 7x plus 18. Okay, now there is no greatest common factor for all 3 terms, so therefore we are going to have to go ahead and find the magic number. So 6 times 18 would be 60 plus 48, also known as 108. We're then going to find the factors of 108. Unfortunately, there are many. Let's see, we have 1 times 108. We have 2 times 54. We have 3 times 36, I believe, yes. We have definitely 4 times 27. Yeah, 4 times 27. Not 5. Not, does 6 go into it? It might. Yes, 6 times, I think 18 actually. Does 7 go into it? I don't think so. Does 8 go into it? No. Does 9 go into it? Yeah. 9 times 12? Yep. Does 10 go into it? No. Okay, so we've just exhausted all those factors. We then also do all the negative versions of those. Negative 1, negative 108. Yeah, let me save time by being fancy and moving this down here. Let's actually erase that. Let's erase that one. We're going to go ahead and just copy these and bring it down here because I'm being lazy. We're going to put a negative in front of everything. Simple as that. Okay, so now what we're doing is we're finding the pair that works at this point. In other words, which pair adds to a negative 7? Anything? Yeah, so my student watching, you might be pleased to know that nothing adds to a negative 7. Now, why would you be pleased to know that? Well, you'd be pleased to know that because we now know that we're done. Since we found the magic number, we factored it, and we cannot accomplish step number 3 because there is no pair that adds to that negative 7, so we're done. Now, let's take a look at the directions really quick. The directions said factor each polynomial if possible. If the polynomial cannot be factored using integers, write prime. Okay, so this is what we call prime. So in other words, we cannot factor this using integers, and the way that we know that is the fact that we could not accomplish step number 3. All right, so anytime you cannot accomplish step number 3, then you know that you cannot factor the original trinomial, and therefore you know that it's the case that it's not factorable, and therefore it is prime. Okay, so that's that one. So that turned out to be awesome because we saved ourselves a little bit of work, right? So looking at the last problem, which is 18 plus 11y plus 2y squared. All right, so in my opinion, they're being annoying with that because at the end of the day, we could just rewrite it to say 2y squared plus 11y plus 18. And then we could factor that in the same way that we've been factoring everything. We could just change the order first and take it from there. So let's go ahead and do it. So the magic number is 2 times 18, which is positive 36. That's step number 1. Step number 2. Find the factors of the magic number. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. And then, of course, it will be the negative versions of those, right? The negative versions of those. So I'll write them down here. We're going to put a little negative in front of everything. Negative, 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 negative. Negative, 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 negative. Then you ask yourself, find the pair that works. Step number 3, what adds to positive 11? Nothing. Nothing adds to positive 11. And therefore, we're done. This is prime. How about that? Isn't that amazing? Let me just double check. Yeah, 6 plus 6 is 12. 4 plus 9 is 13. 3 plus 12 is 15. Yep. Yeah, nothing adds to positive 11, so we're literally just done. So anyway, that's how you do it. For my student watching, don't be scared by that one particular batch of problems that had to do with factoring the variable uh, number, sort of the last batch of problems that we did on the last slide. The chances of having a lot of questions like that on the assessment is very low. The most important skill is the first batch of problems skill and the skill involved with this batch of problems. And by the way, that includes factoring out the greatest common factor right away when facing a problem like problem number 13. It is the case that you should know that upon looking at 3y squared negative 6y negative 24, that there is a greatest common factor of 3 with all 3 terms. Therefore, you should factor that out right away. Okay, so that's going to become this. All right, so hopefully that makes sense. And then at that point, you would just factor that. So also, when you're factoring this, don't forget to write the 3 on the final factorization, right? So it's going to be plus 2 minus 4. Okay. So anyway, hopefully that was helpful for my student and for those of you watching who are not my student. Hopefully that was helpful for you as well. Anyway, that's it. And I will talk to you later. Bye.